Hello, in this video we will show how to calculate the comparisons between different treatments in ANOVA using a function called TukeyHSD function in R. So in last video we have seen that ANOVA is just a test, so using AOV function, so ANOVA AOV function, and this function, the result will have an F-test statistic which shows that all treatments, these treatments can be 3 treatments or 4 treatments or 5 treatments. So this test tells that all treatments have no difference or they have difference. So which means if any of the 2 treatments significantly different, so this F-test from ANOVA will say that the treatments are different. So this means it's most probably the F-test from ANOVA will be significant, because it's only one chance that all the treatments are same, have no significant difference, then this test will be not significant, right? And if you want to know how much is the difference between the pairs of treatments, then we will show another function called TukeyHSD. So this function will be done after we have done the F-test from AOV function. So next we will show an example. And actually, first we will do the same thing from the last video. So we get a data called crossrow, and from this package multcomp, you have to install this package first. And we used the dplr package to do some data management. So we create a data frame called plot data, and this data frame comes from crossrow, and a crossrow data frame will use this variable called trt with a function called group by, because we want to see all the information from different treatments. So this is the treatments, and then after the grouping of treatments, then we will show how many observations for each experiment or each treatment, and what's the mean value of the response. This is a dependent variable response from this data frame, and what's the standard deviation of this variable for each group, each treatment, and also the confidence interval for these different treatments. Then we will show this plot data, treatments 1 time, 2 time, 4 time, and these other 2. So totally there are 5 treatments, observations, and mean value, and standard deviation, and confidence interval. Then we will do ANOVA first, AOV function, with the response as the response is the dependent variable and the treatment is independent variable. Then we show the results. So the results from ANOVA AOV function is significant. This p-value is very low, and this is the F-test results. Then we'll show plotting the different treatments for different groups. So this is the treatments and their mean value and confidence interval. So next we will show the contents of this video, what we focus on for TukeyHSD pairwise group comparisons after ANOVA function. So we first will create an object called pairwise, and using TukeyHSD for the fit. This fit is actually the result from ANOVA function. And we will show what's the pairwise. So pairwise is information and with a an element called treatment, TRT. So this actually shows pairwise because we have 5 groups, so there are pairwise 10 difference between each group pair. There are difference and the lower bound and upper bound and the p-value. So you can see the p-value if lower than 0.05, so which means the difference is significant. And for example, 2 times against 1 time, this is not significant because p-value is larger than 0.05. And most of them are significant, almost 0. About 1, 2, 3. 3 not significant, and 7 are significant with a difference. So this is the reason why the F-test for ANOVA is significant. Then we can also plot this information. So we get a pairwise, because these are list objects, we will use double brackets and get information to create a data frame called plot data. Then we will show plot data. So actually it's a very simple, the label, and for the difference, lower bound, upper bound, and p-value. And then another variable called conditions we created in this statement. So next, similar as before, we will show the plot for this difference using the plot data object, and AES X is for the condition and Y is for the difference. Then we create an error bar with the lower bound and upper bound, and we create a horizontal line with 0, because if the error bar covers 0, which means this is not significant with from each other pairwise. And we also create points with the size and the color. Then is a theme for whole appearance for the plot. Then with a label, and in the end we set a coordinate flip. So coordinate flip, which means transform the plot from vertical to horizontal and vice versa. So we will run. So now you can see the label now becomes the vertical object, the variables, and the difference in horizontal. And this is error bar. You can see 3 error bar, and covers 0 value. So which means these 3 pairs not significantly different, and the other 7 are significantly different. Thanks for watching.